The section's on 3.3, analyzing graphs of quadratic functions. So we're going to go ahead and build on what we learned on 3.2. Okay, so we still have as a quadratic equation, we have as f of x is equal to ax squared. So remember, wherever there's an x squared, the coefficient is a. Wherever there's an x, the coefficient is b. And then the c is the number by itself. Now, you can also see f of x the same thing as y equals. So sometimes they have a y equals or they have f of x. F of x just basically says it's a function. So that's the reason for f of x. Okay? So one of the things you're going to do is find the vertex. Now, finding the vertex depends on what method you use. So if you remember in 3.2, we had 3 different methods to solve for the roots. We did the big X method, then we did the completing the square and the quadratic formula. Now to find this, we're going to do 2 methods. It's either completing the square or the quadratic formula. You're not doing both of them. Okay, so this is all based on your preference. If you like completing the square, you're going to go follow through with completing the square method. If you like the quadratic formula, then you're going to follow through using the quadratic formula method. So now on this part right here, this is for completing the square. So when you have a completing the square, if you remember from 3.2, we did the same thing where this is the a, that's the number that we factored out. Then we have is this perfect squared right here. And then on the other one, we solve for the roots, so we set it equal to 0, and we actually brought the k over to the other side, and we went ahead and solved it for the x. So in this format right here, the vertex, we're actually going to be on the first step is to actually leave the k on this side of the equal sign. So that way when we pull this thing together, the final answer is the h and the comma and the k. So the h is coming from here. And notice that this is minus right here, so it's the opposite sign. So if this is negative, when you put it inside here as your final answer, it becomes positive. And then vice versa. If this is positive, when you pull it into here, that's going to be a negative. The k is whatever the sign is out here. So if this is positive k, so is this right here. If this is a negative k right here, so is this right here. Okay? So this method is to find using the completing the square. Now, if you do the quadratic formula, you're going to have a different way. So the quadratic formula is negative b divided by 2a, and then plus and minus the square root of b squared minus 4ac, all divided by 2a. Now this right here, the quadratic formula, notice I split it. I split it into 2 parts. This right here is the reason why is because I actually want just that part, and that's going to help us to find the h, which was this part right here. Okay? Now to find the k, I would take this, substitute it back into the original equation for wherever there is an x, substitute it that, get the y number right here, and that's going to give us the k part right there. Okay, so this part right here using quadratic formula actually takes 2 steps because you have to solve for this, get this number, substitute it back into the original to figure out what the k is. Whereas if you do completing the square, you just set the format and then from there just pull out the numbers from there. Okay? All right, next one. Axis of symmetry. So axis of symmetry is found by the h right here. So we say x is equal to h, that's the axis of symmetry. The axis of symmetry is a line that goes through the vertex. Oh, did I mention? The vertex is the tip of the parabola. So the axis of symmetry goes through the tip of the parabola and it becomes like the mirror line saying that the left side of the parabola is a mirror reflection of the right side of the parabola. Okay? Then we have is a max and min. Now max and min is all determined by the a. So if you remember, a goes back to the original equation right here, which we found either to be a positive or a negative out here. So if it is a positive number, that means it's greater than 0. The parabola is going to open upwards, right? And so because it opens upwards, you're going to have a minimum point on the vertex. If the parabola or the a is less than 0, meaning it's a negative, it's going to go up and opening downwards, right? And if it opens downwards, then you're going to have as a maximum point on your vertex. Okay? Next one we're going to find is the roots. So roots is finding by completing the square or the quadratic formula, which we did in 3.2. So that's the one you did, and you had to find 2 answers. So that's this part right there, finding the roots. Then we also have to do is the graphing. So this is the graphing. Make sure you graph it out using the x and y, and also on the parabolas, make sure that both ends of the parabolas have an arrow because they do go on to infinity. Then we're also going to find the intervals of increasing and decreasing. Now, the intervals of increasing and decreasing is reading the x-axis. So we're not reading the y, we're just reading the x. And when you read on the increasing and decreasing, you always read from the graph from left to right. So whatever the smallest number is from the left side to the right side, that's your increasing and decreasing. And then the last part is the range, which is then reading the y-axis. So it's going from bottom to top of the range right there. Okay? So I'm going to show both methods so that way you can see which one you prefer. So we're going to go with completing the square first, and let's see what that gives us then. So completing the square, we're using this equation, f of x is equal to negative x squared minus 8x plus 5. And to complete the square, the first step is to group the a and b together. So that's what I did on this step right here. I grouped them, and I want to keep the plus 5 on the outside. Now, the reason why I want to keep the plus 5 on the outside is, remember, going back to the formula, that's going to eventually give us this k part right there, which we need. Okay? So that's why we want to keep it out there. Then we want to factor out, because remember we said in 3.2, you cannot have a number or a sign in front of the x squared, which is the a. So since this is negative, we're going to factor it out. We have then is, if I factor this out, the sign changes right here as well, because if I distribute this, negative 1 times x squared should give me negative x squared. Negative 1 times positive 8 should give us then the negative 8x. Okay? So nothing has changed right here yet. So from here, all I did was factor out. Now, from here, then we do that half of the b squared. So I took then, right here, 8. Half of 8 is 4. We're going to go 4 squared right here. Now, on this right here, what happens then is I also need to put that 4 squared. Remember, we did on the other one, on 3.2, we put it on the other side of the equal sign, and we just balanced it by doing the same sign. But what happens on this one, the format is everything needs to be on the same side right here, and we set it equal to 0, and we don't touch this part yet. So when I distribute this right here times this gives me negative x squared, which is the original formula right here. This gives me the original formula, which is negative 8x. And again, we mentioned this is the man-made, which we just created. Okay, so since this is negative 4 squared is 16, and then since we're on the same side of the equal sign, this actually is going to become the opposite. So since that's negative, I have to do is plus 16 instead. Because what I want to do is make sure that this cancels out right there to a 0 right here. Okay, so that's why. Now on the other one, we did 3.2 solving, we actually did the same sign, right? So if this was positive, then so was this. If that was negative right there, then so was this right here. But since we're on the same side of the equal sign, you want to cancel out to 0 because we're saying it's equal to 0. You want to do the opposite sign instead. Okay, so then let's continue on. So I'm going to keep that negative right there. We're going to go into perfect squares. So perfect square says I keep my variable, I keep my sign from the b, right? So we drop that down. We bring this 4 right here, we drop that down, squared, and then we continue to add this together. So 5 plus 16 gives us what, 21? So plus 21 and equals 0. Okay, so now I'm ready actually to go ahead and pull out my h and k's. So my h, remember we said, was found from here, so it's always the opposite sign. So since this is positive 4, it's going to be negative 4 for my h. And my k is this part right here, which is then 21 right there. Okay, so that's the vertex. Then we continue on to find the axis of symmetry. Axis of symmetry, the formula was finding from the h right here. So since x is equal to negative 4, that's my final answer right there. Okay. Next one, maximum minimum. So maximum minimum was determined from the a. So from here, remember the a was negative. If a is negative, it's going to open downwards. So therefore you have a maximum instead. So we're just going to get a maximum. And that's all you need to tell me is if it's a maximum or minimum. Okay. Now finding the roots. So that's the work part of it. So we're going to have to continue on. So then the nice part of this is that we kind of already set this up right here. So I have then is then negative x plus 4 squared plus 21 equals 0. And then I can just continue to solve it like I did on 3.2. So on 3.2, then we brought the 21 over on the other side. So I have as x plus 4 squared equals negative 21. Then we divided by negative 1 on both sides right there. So we have as x plus 4 squared is equal to positive 21. Then we want to square root both sides to get rid of the squared right there. So we square root. And so then we have is x plus 4 equals, and then remember this gives us two answers. So it's positive square root of 21 and then also negative square root of 21. So I guess we can just do plus and minus for right now. All right, I'm going to have to split it up because I need two answers from there. So the next step, and then split it up right here. So then we have is x, and we're going to bring the 4 over to the other side by subtracting 4 on this side. Okay, so then two answers I have. So one of the answers is then positive square root of 21 minus 4, right? And then the second one is going to become negative. So x equals negative square root of 21 and then minus 4. Now, the 21 for right now, we're going to leave it since we're going to graph it out. I would then ask you to put it into your scientific calculator and work out the numbers. So when you work out the numbers, one of those should give us then negative, I believe this one's going to give us negative 8.58. And then this is going to give us then 0.583, somewhere around there. Okay? So from here, this is the roots. So we need these numbers right here to graph it, because then that becomes on the x-axis. So let's say this is like negative 2, negative 4, negative 6, negative 8, and this is negative 2 as well. Oh, I'm sorry, positive 2, positive 2. So then one of them is negative 8 point something, so that's going to give us then somewhere around here, right? And then the other one's going to be positive 0.58 something, which is approximately 0.6-ish. So it's going to be somewhere around here. So we got our roots. Now I need my vertex. So going back to here, somewhere up here, my vertex is at negative 421. So negative 421, I'm going to approximate up here is my 21. So up here. So those are the 3 dots I need. So from there, I just connect the 3 dots. So here we are. Then I'm just going to go this way. And we said it was going to give us a maximum, right? Because it's going to be an upside down parabola. So it's going to go through here, come around here. It's going to have a nice curve to that right there. So this is the graph right there that we're going to go ahead and sketch out. Okay? The axis of symmetry we said was that x equals negative 4. So now axis of symmetry is not a real thing. So it's going to be a dotted line right here. And this is kind of like the imaginary line right there. So when we do this imaginary line, that means that if I fold it at x equals negative 4, this side right here should be symmetrical to this side right here. That's what it means right there. Okay? Also, what helps is if you know what the axis of symmetry for the increasing and decreasing for the next part, that helps out as well. So for the increasing and decreasing, you read always the graph from the left to the right. So starting from the left side, so from here, I'm reading just the x-axis. So I'm going from here, and if you notice the graph is going upwards. So since the graph is going upwards, it's increasing. So for the increasing part right here, we're going to say it's increasing. Now, for the x-axis, because I'm reading from the left side right here, I don't know where this is, because this is going to go to infinity. It's actually going to keep on going downwards. So on the x-axis, I don't know quite where it's actually going to start from. So since I don't know, we're going to say it's going to start somewhere from negative infinity, because it's going way out here somewhere, right? Because as this goes downwards. But it's going to increase all the way up to the x-axis of this right here at negative 4. So we put in negative 4. Now, negative 4 is also going to be a bracket right there because it's a finite, meaning that we know for sure it stops at negative 4. So that's why it's negative 4 as a bracket. The infinity is always parentheses because we don't know. It's not a finite number. It's an infinite number because it continues on forever. So that's why this part right here is the parentheses right there. Okay? As we continue to read the graph, we stop right here. So now from here, if you follow the graph, notice it's decreasing. It's going downwards. So it's decreasing on the x-axis of negative 4. So it's going from negative 4, and it's decreasing to the x-axis of, and this also continues on forever this direction. So I don't know where on the x-axis it'll stop. So because of that, we're going to go ahead and put infinity right there. Okay? So it's reading from left to right. So from left to right, I know from this graph to this graph, it's increasing. And then I also know from this graph to this graph, it's decreasing right there. Now the opposite end is the range. So So for the range, we need to find the y-axis. So using the y-axis, we're reading from bottom to top. So on this graph right here, the bottom of this graph, both of these guys are going downwards on the y-axis. So I don't know exactly where on the y number it'll actually stop. So the same idea as this one right here. So because we don't know where it's going to stop, we're going to go from negative infinity on the y-axis, and then we're going to go to where is it stopping on the y, which is up here. And the y number that it stops at is 21. So 21 is where we're going to stop at. And again, 21 is a finite number, meaning that I know for sure it stops at 21. So therefore, it's a bracket right there. Okay? So that's the range part right there. All right, so that's all of this using now completing of the square method. Now let's go the other one, which then is the quadratic formula. So going through the same steps with the quadratic formula now, and I'm going to do the comparison of the quadratic with the completing the square so you can see where it comes in. So using the same equation, so that way we can compare it, we're going to go ahead and find the vertex. So to find the vertex of the quadratic formula, we have to use the quadratic formula part right here. And remember we said we took this first part right here, that's going to give us then is the quadratic part of it. And so if I put that together, I'm going to have is x is equal to negative, and then in this case our b, right, our b is negative 8, so then I have is negative 8 all over 2 times a, which is negative 1. So then it simplifies to, what's that, positive 8 over negative 2, which is negative 4. Okay, so negative 4 is the x number, which then gives us the h that we needed, right? Because if you remember going back to the formula we talked about right here, this gives us the h right there. So that's this part right there. And so I need a k. To find the k, I substitute this back into the original equation. So let's go ahead and do that. So if I substitute this back into the original equation, so wherever there's an x, we're going to go ahead and put a negative 4. So we said f of x is the same thing as y equals. So I'm going to go ahead and put y equals negative 4 squared minus 8 times negative 4 plus 5. So this is the equation right here. We just substituted negative 4 into all the x's right there. That's this part right there. Okay, so then we calculate this out. Just put it in your scientific calculator, work it out, and that should give us then 21. So this is 21. So once I know what this is, then this becomes this right here, the 21. Okay, now let's go back and compare it to which we did using completing the square. So completing the square was exactly the same answer, negative 4, 21, negative 4, 21. So you can see it's going to give us the same answers, but it's just a different method. So depending on which method you prefer, you're going to work that out. Okay, so once I get the vertex, then we're going to find is the axis of symmetry. And we said axis of symmetry is the h, which is at negative 4. So this is the simple part right there. Okay, then we do maximum minimum. So maximum minimum is the same idea as the previous one. We can just go where a is right there, determine if it's max or min. So since it's negative, the parabola is going to be upside downwards, right? So we know for sure we're going to have is a maximum right there. So we can circle maximum right there. Okay, now to find the roots. To find the roots is what we did on 3.2, which is the quadratic formula, is to continue and finish this problem up here. So if you remember, this part right here, it was the beginning part right there. So then we have to finish it up using the back part of the quadratic formula. So let's go ahead and do that. So I'm going to go ahead and write x is equal to, and I'm going to split that up to what I had shown on this part right here, the split up, so you can see that this is already calculated. We already calculated that part. We just need to calculate is this part now for the quadratic formula. So you did half the work. So that's 2a, and then plus and minus the square root of b squared minus 4ac all over 2a. So we said this first part right here is negative 4, right? Because that's what we just did right here. That's the negative 4. So I can actually substitute that as negative 4. And then I just need to work this last part. So b squared. So b is, again, negative 8. So we have is negative 8 squared minus 4a is negative 1. So negative 1. And c is positive 5. So positive 5. Okay, all over, and then 2 times a, which was, again, was negative 1. Okay, so as I continue on, we have is negative 4 then, plus and minus the square root of 8 times 8 is 64. And this is positive right here because it's negative times negative. So that's positive 20 all over negative 2. So then that's going to give us, let's see, 84. So negative 4 plus and minus the square root of 84 over 2. And again, then from here, you just put into your scientific calculator, and you're going to split the problem up. So you're going to have is one of the problem is going to be negative 4 plus the square root of 84 divided by 2. And then the other problem will be x is equal to negative 4 minus the square root of 84, right, over 2. And so then from here, it should give us the same roots. So it should give us x is equal to, and then one of them should be the 583. And then the other one should be that x is equal to negative 8.58. Okay, so those are the roots now. So that gives us the roots. So then from here, which is going back to the one we just did on completing the square, that gives us that negative 8 point something that we mentioned up here, right? And then also the 0.583. So then we do exactly the same graphs. We still use that vertex we found to be what, negative 421. So negative 421. So everything then follows exactly the same. So the only difference then is the method is going to split up, is finding the vertex and finding the roots, because then from there everything else becomes the same. So once we find the roots, we graph it out, we then do the increasing and decreasing, and again the same thing, increasing and decreasing. So reading from the left side of the graph, you read it this way, and you find that this graph on the x-axis is going to continue. So you're going to start at negative infinity. It's going to go all the way up increasing, and it stops at this point at negative 4. So that's where we have negative 4. Remember, it's a bracket because we know for sure it stops at negative 4. And then decreasing is then going the opposite direction. It's going from here, and it's going to fall backward or fall down. So that's our decreasing. So starting at negative 4, going to positive infinity. Then we have is the range, which is the y-axis. So you're reading from bottom to top. So this is the bottom, this is the top. So the bottom of the equation is I don't know where these guys stop at. So because I don't know where it stops at, it becomes negative infinity is where we're starting from the bottom. And it ends all the way up in the top of the y number at 21. So this is why this 21. Okay, so everything else is the same. So again, the only part then you're going to find difference depending on what method you use on the vertex, and then also finding the roots, because then once you find the vertex, it sets you up, and then you just need to finish it to find the roots. But everything else, axis of symmetry is the same, finding minimum and maximum is the same, and then finding increasing, decreasing, and also the range as well. Okay, all right, so then we'll be ready for the classwork.